Hello, boys and girls. My name is Stephanie Finn, and I am the Science TOSA for the district, part of the Division of Curriculum Assessment and Instruction. I am here today to talk to you about the moon and moon phases. So I have a few questions here today that I want to discuss with everyone. Have you ever wondered why the moon seems to change its appearance over time? So one night you might be looking outside and you see the moon is very full, and then a few days later you might go out and see that the moon might appear to be smaller in size, or it might not even be there at all. Have you ever wondered why we can see the moon during the day? Maybe we should only see it at night? We'll talk about that. Have you ever wondered what the moon is made of? Have you ever wondered if anyone has ever walked on the moon? And finally, if we can't see the moon, is it still there? We're going to try to answer all of these questions in this segment about the moon and moon phases. First of all, what is the moon? The moon is a celestial body or a natural satellite that orbits or revolves around a planet. So for us, our planet is Earth. And here is a model of planet Earth. Our moon is a natural satellite, and this satellite revolves or orbits around the Earth in a predictable pattern. Now, interestingly enough, there are over 200 moons in our solar system. Mars has 2 moons, Jupiter has 79 moons, and Saturn has 82 moons. Our planet, again, only has 1 moon. The moon is a rocky moon, and it's composed of rocks similar to igneous rocks found on Earth. Remember, igneous rocks come from volcanic activity. And finally, we can see the moon because it reflects light from our sun. So what is the difference between a moon and a planet, and why isn't a moon a planet? So a planet, like our Earth, is a celestial body that orbits or rotates around the sun. A moon is a satellite or a celestial body that revolves or orbits around a planet, in our case, planet Earth. So with this, because our moon rotates and we have a system of sun, Earth, and moon, we have moon phases. Now, for the sake of consistency, we're going to pretend that this space out here is our sun. Then we have our moon, and then we have our Earth. And this is a non-scaled model representation of the sun, Earth, and moon system. So we have moon phases. It takes about 28 to 30 days to orbit or revolve around the Earth. So it takes about a month for our moon to orbit or revolve around the Earth. Have you ever heard the phrase, once in a blue moon? The moon really doesn't turn blue, boys and girls. What happens with a blue moon is we have a full moon. Full moon would be here, this position. We have a full moon twice in 1 month. So if you hear somebody talking about we have a blue moon, that means that we have a full moon occurring twice in 1 month, or twice within a 30-day time period. I'm going to put it back on the new moon phase. Moon phases happen because the sun, the Earth, and the moon interact, and they cause each phase of the moon to have a specific appearance. And our moon follows a very predictable pattern. To begin to understand the moon phases a little bit more clearly, we're going to model a few activities. So first of all, what are the phases of the moon? So I'm going to introduce a few vocabulary words, and then after I introduce them, I'm going to show you what they look like. The first is a new moon, and then we have a waxing crescent, first quarter, waxing gibbous, full moon, waning gibbous, third quarter, waning crescent, and new moon. Now, if you notice, all of our waxing occurs before a full moon, so when our moon is waxing, it's getting larger in appearance, and then when it's waning, it's getting smaller in appearance. And I want you to, if you can remember those phrases, waxing, getting larger, and waning, getting smaller, that will help you remember the moon phases a little bit better. So what we're going to do is we're going to do a physical model of the Earth's changing phases. I want to talk to you about what is a model first. A model can be a two-dimensional representation, meaning a diagram or a picture, or in this instance, a three-dimensional representation of our system of the sun, which is going to be out here, the moon, and the Earth. This is not to scale, meaning this isn't an exact replication of the size of the Earth compared to the size of the Earth that we live on, and the size of the moon compared to the moon that we see in the sky. So this is a non-scaled representation of the Earth, moon, and sun system. So let's get started on this. First of all, we have a new moon. And when we have a new moon in the sky, our new moon looks like this. Can't really see anything. This would be the position of where the new moon is in relationship to the sun and the Earth. So you can see that because the moon is between the sun and the Earth, it's blocking the sun's rays at that point, so we can't see anything here on Earth. And here is North America right here. This is a new moon. After the new moon phase, our moon is getting larger, so we're talking about a waxing crescent. This is what we see with a waxing crescent. A waxing crescent, the moon is about here. So the moon is about here in our system of sun, moon, and Earth. And then we get to the first quarter. Now, we call it a quarter moon because we can really only see a quarter of the moon. Remember, the moon is a sphere. Now, it looks like a half moon, but it's not a half moon because it's three-dimensional and only a quarter of it is lit on Earth. So that's why we call it a quarter moon, and it's our first quarter. After the first quarter, we have a waxing gibbous. So some people call this a three-quarter moon. Remember, we're talking about waxing. The moon's appearance is getting larger. And for a waxing moon, our moon is about here. Remember, boys and girls, this is non-scaled. And then of course, we have our full moon. Our full moon looks like this. Everybody knows what a full moon looks like. When we're in the full moon phase, our moon is right here, and it's reflecting direct sunlight off of the moon, bouncing back on Earth, so this is where we see our moon. Boys and girls, when we come back, we're going to talk about the rest of the moon phase cycle and when we can see these phases in the sky. Welcome back, boys and girls. So we're right in the middle of our moon phases for the month. I just want to review what we've learned so far. We started off with our new moon, which looks like this. And the new moon, our moon is in this position. And then gradually we're going into waxing crescent, first quarter, waxing gibbous, and finally a full moon. And the moon is in this position. This is what we see on Earth, a full moon. Then our moon is starting to wane or get smaller as it continues its revolution or orbit around Earth. After the full moon, the moon phase is called a waning gibbous. And in a waning gibbous, our moon is about here. And then after the waning gibbous, we hit the third quarter. So our third quarter, again, it's waning. Our moon is getting smaller. Our moon is about here. After the third quarter, we have our waning crescent. And then finally, back to our new moon. And remember, with a new moon, the moon is still out there. We can't see it at night because it's blocking the rays of the sun where it is when we see it from Earth. So, when do we see the moon? Is the moon out there all the time? When we see the moon, it depends on where the moon is in its orbit around Earth. I want to go over this with you guys again. So, the new moon, this is when we don't see the moon at night, but interestingly enough, it rises and sets with the sun. So when you see that moon, that full moon during the day, that's a new moon. Following the new moon, we have the waxing crescent. Moon is in this position. And you can usually see it for a short time around sunset. We're right now between this phase, and a few nights ago when I went outside, I was able to see a waxing crescent in the western part of the sky. So if you're looking west towards the lake, you would see that waxing crescent pretty much around sunset. Then we have our first quarter, and we are transitioning into the first quarter now. Today is August 24th, so this is our first quarter. And you can see it in the afternoon and evening. First quarter, afternoon and evening. Then we have our waxing gibbous. Remember, boys and girls, waxing, our moon is getting larger, waxing gibbous. Some people might refer to it as a third quarter moon. This is our waxing gibbous. And you can usually see this from sunset until sunrise. So this is one of the moons that we see at night. And finally, that full moon. We call it a full moon, but actually only half of the moon is being illuminated by the sun or lit by the sun. And this, we can see it all night long. So on a moonlit night, it's very bright in the sky. Remember, the light does not come from the moon. The moon is actually reflected from the sun in our solar system. So the moon does not have its own light. It's reflecting light from the sun. Following that full moon, we have our waxing gibbous. And remember, our waxing gibbous, we can see it from sunset until sunrise, but waning. So now it's going from our full moon, and it's getting smaller, so it's waning. It's getting smaller. After the waning gibbous, we're going to come across our third quarter, and we can see this from about midnight till about noon. You'll be able to see the third quarter. Our waning crescent, so here is what our waning crescent looks like, and you'll be able to see this from midnight till about noon. And then we get back to our new moon phase, and we'll be able to see our new moon all day during the day. Now I'd like to show you a computer simulation. This is a computer simulation where we are going to see what we talked about here. We have our sunlight coming in at this angle, and I'm going to select new moon because that's where we started. This is a position of the moon in the new moon phase. We can see our Earth is right here. This is what we would see at night or in the evening. We wouldn't see a moon because remember, during a new moon we can see it during the day. Then we have that waxing crescent, and remember, waxing means that we're able to see the moon, so we can see that little sliver, that little waxing. This is where the moon is in relationship to the Earth and the sun. After the waxing crescent, we have that first quarter. It looks like it's not really a half moon. Remember, it's a quarter moon because the moon is a sphere. It's a solid sphere. So first quarter, it's a quarter of the moon is being lit by the sun. After the first quarter, we have our waxing gibbous. Remember, waxing is getting bigger still, so we can almost see the moon. Some people might refer to this as a three-quarter moon. Then after our waxing gibbous, we have a full moon. So if I were to demonstrate on our model here, We've gone all the way to here, full moon in the sky. When the sun, earth, and moon are lined up in this position, we have a full moon. Following the full moon, we have our waning gibbous. Moon is getting a little bit smaller. Remember, waning gets smaller. Following our waning gibbous, we have our third quarter. We're able to see 1/4 of the moon, but it's the third quarter. Our waning crescent. This is what we see in the sky, our waning crescent. And then we get back to our new moon. So I'm just going to play this for you for a couple of rotations so you can see it in its entirety. The first time I play it, boys and girls, I want you to pay attention to the larger square. The second time I play it, I want you to pay attention to the smaller square. All right, now the moon is waxing, it's getting larger. Then we get our full moon, we can see it visible at night. And then moon is waning and getting smaller. All right, sorry about that in the middle.
Sorry.
I can't believe I did that. I'm like, welcome back, boys and girls. Now we're going to talk about, has anyone ever been to the moon? Well, not in your lifetime, but in maybe your parents' lifetime or your grandparents' lifetime, and in my lifetime, 12 men walked on the moon from 1969 through 1972. The first two astronauts were Buzz Aldrin and Neil Armstrong, and they performed their walk at the end of July in 1969. Some of you might have remembered last year was the 50th anniversary of this historic moonwalk. There were 6 Apollo missions that brought humans to the moon: Apollo 11, 12, 14, 15, 16, and 17. Now you may wonder why there's not a 13. There was an Apollo 13 moon mission. However, the moon mission was stopped in the middle of the mission due to a problem that they had with the oxygen tanks on board the spacecraft where the astronauts were. They never made it to the moon, they orbited the moon, and they came back all 3 down to Earth safely. What I want to show you is a montage of video clips of moon landings from various Apollo missions. And these are really fun to watch. It's going to be about 3 minutes in length, but I think this shows the best of what our astronauts experienced on the moon with their moon landings.
Holy crap, it's beautiful out here. It sure is. It's something else. Man, I can't wait to get outside. Look at that. It's a nice place to land.
Hello there, from the men on the moon.
Okay, forward hatch is open. Lower your visor. Alrighty, starting out the door.
Man, that may have been a small one for Neil, but that's a long one for me.
Beautiful view.
Isn't that something? Magnificent sight out here.
Magnificent desolation.
It's a great honor and privilege for us to be here representing not only the United States, but men of peace of all nations. honor for us to be able to participate here today.
I think that's pretty good. After only 10 years, here we are spending 3 days on the moon. That's moving ahead.
It's super. This is going to be a good day, Charlie. Why don't you run around and pick up a rock? Hey, outstanding suggestion. Give me a rock bag, Charlie. The little ones or the big ones? Oh, is this a neat way to travel? Isn't it great? I like to skip along.
Hey, this is the cleanest place I've ever been in my life.
Woo!
Dust is everywhere.
Let me throw the hammer, please. Oh, you're a geologist. You ought to be able to throw it. You ready for this?
Yeah, don't hit the lamp.
Look at that. Look at that. Look at that.
I'm sure there's another good rock around here that I've been eyeing out my window. I wanted to get anyway.
That's a big rock there. Sure is. Good picture. Go ahead. You get the tube? Yep.
Okay, Houston, we're underway. Yow! Woo! Man, that's a great big skid.
Well, in my left hand, I have a feather. In my right hand, a hammer. And I guess one of the reasons we got here today was because of a gentleman named Galileo a long time ago who made a rather significant discovery about falling objects in gravity fields. So we thought we'd try it here for you, and I'll drop the two of them here, and hopefully they'll hit the ground at the same time. How about that?
Golly, covered me with dust on that one. Sorry, Charlie. That's okay. Hey, John, this is perfect with the limb and the rover and you and the old flag. Come on out here and give me a salute. Off the ground, before. There we go. Good.
Our Airman completed his first exploration of the moon. May the spirit of peace in which we came be reflected in the lives of all mankind. 3, 2, 1, ignition. Right away, Houston. Regs are good. Ag side.
You might have noticed a few things about the video footage. The first one is that you might have noticed that the astronauts were able to take really giant steps, or they were able to throw things really far away from them. That's because on the moon there is less gravity. Now, gravity is that invisible force all around us that allows us to walk on Earth and for objects to fall down if I were to throw something. But because the moon is so much smaller than the Earth, the force of gravity surrounding people and objects on the moon is less. So you might weigh less on the moon, but still have the same mass. That's why the astronauts were able to jump so much further and throw so much further. The second thing you might have noticed is those big spacesuits that the astronauts wore. That's because the temperature on, one of the reasons is the temperature on the moon is so much different than here on Earth. Temperatures on the moon can reach up to 243 degrees during the day, and in the evening at night they can get up to minus 230 degrees Fahrenheit. So there's a great temperature difference. Also, there is no oxygen in the atmosphere on the moon. So the astronauts had to wear those spacesuits in order to breathe oxygen. So, important things to remember. The moon takes 20 to 30 days to orbit or revolve around the Earth. That's about 1 month. So it's 1 month from new moon to new moon. The moon does not have its own source of light. Remember, the moon reflects light from the sun. So when the moon is in its full moon phase, and that's when the moon is here, it is reflecting light from the sun. This is what we see when the moon is in this position compared to the Earth and the sun. The moon also stays in orbit because of Earth's gravity. So that same force that is keeping us here on Earth is also keeping the moon in orbit around Earth. So, getting back to the beginning. Let's go back to those wonder questions that we had at the beginning. Why the moon seems to change appearance over time, we've answered that. That's because it revolves or orbits around Earth. We can see the moon during the day depending on where it is in that orbit. So we can see the moon during the day when it's in the new moon and in the waxing crescent. The moon is made of rock similar to igneous rocks on Earth. 12 men have walked on the moon, and we can still see the moon even though we can't see it on Earth because it is still there. So remember at night, boys and girls, go out and look at the moon and remember all the things that we've experienced and talked about today.